This is Mac 1105, Chapter 8, Section 5, Part 2, Partial Fraction Decomposition. We've already gone over that when you factor the denominator of a rational expression, if the factors are x to the first power, you just use a, b, c, d, so on and so forth. We've also gone over an example where if you have like x to the first power, x minus 1 to the third power, you have to make your fractions as x minus 1, then x minus 1 squared, then x minus 1 to the third power. This is the third rule, and this is where, like for instance, the rule stays the same. We've got to factor the bottom. This is a difference of squares, so it becomes x minus 1 times x squared plus x plus 1. Notice this factor has a degree of 1. This factor has a degree of 2. Whenever you have a factor that has a degree of 2, then what happens is when you split them up, this one still stays a, but the top, when you have a degree of 2, becomes bx plus c, like your y equals mx plus b. So let me rephrase that again. You know, anytime one of your factors in your denominator is the first power, okay, then you're just using a letter from the alphabet. But anytime one of your factors has a second power, then you're dealing with your linear form of your equation, bx plus c. Notice I still stay with the alphabet, a, b, c. The procedure is still the same. Okay, once we set this problem up, you can see that what we're going to do is multiply by the denominator of the rational expression over 1. So when we multiply this over 1, we just get 3x minus 5. If we take and multiply this times this, the x minus 1's cancel, and we end up with a times x squared plus x plus c. If we multiply this times this partial fraction, then the x squared plus x plus 1 cancels, and we get bx plus c times x minus 1. So then what happens is now what I'm going to do is, first of all, I realize I'm going to have an x squared term, so I'm going to put this 0 x squared over here. Remember, this has to be in perfect descending order on both sides. When I distribute here, I get ax squared plus ax plus a. Here, this is a binomial times binomial, so I'm basically going to multiply the first times the first, get bx squared, bx times minus 1 minus bx, c times x cx, c times minus 1 minus c. Now remember what we do. Because we have an x squared over here, let's group all our x squares together. We've got ax squared plus bx squared, so we have a plus b x squared. In terms of this, I've got this 3x to the first power, so I have ax to the first power. I have minus bx to the first power and cx. So I have a minus b plus cx. Notice that if I distribute this back, see, this would give me my cx, this would give me my minus bx, this would give me my ax. Same thing here, this gives me my ax squared, and this gives me my bx squared. What I have left then is I have this minus 5, which is going to equal a plus c. And so when you come down here, that's exactly what we got. So what happens is that 0 becomes a plus b, because if we look at this right here, that's a 0x squared. This is an a plus b x squared. So 0 equals a plus b, which is what I have here. Here I have 3x to the first power. Here I have a minus b plus c to x to the first power. So I have 3 equals a minus b plus c. That's my second equation. This one I have a constant of minus 5, which is a minus c. So minus 5 equals a minus c. So there's my three equations that I have to use to solve. So remember, with a system of three equations, it doesn't matter if we get rid of the a first, the b first, and the c. I'm looking at this, and it's looking to me like I want to get rid of the a's, because a is in all three equations. So we'll take the top equation and the middle equation. And here I multiply the middle equation by a minus 1. Add them together. I get negative 3 plus 2b minus c. Then what I'm going to do is I'm going to take the top equation with the bottom equation. The middle equation with the bottom equation. Sorry. And I'm going to multiply that bottom equation by a minus 1. Add them together, and I get 8 equals minus b plus 2c. So now I have two equations in two variables that are the same. So now I bring those two equations together, multiply the negative 3 plus 2b minus c by 2, so I'm going to get rid of the c's. When I add them together, I get 2 equals 3b, so b is 2/3. Now I can take this original equation of c equals a plus b. I can put 2/3 in for b, subtract it over, and I find out a is negative 2/3. Once I know a is negative 2/3, I can take the minus 5 equals a minus c, put that negative 2/3 in for a, and all I did here was change that negative 5 to negative 15/3, so that when I added the 2/3 over, I got negative 13/3. Then when I multiply by a negative, I get c equals 13/3. And so now I have a, I have b, and I have c. All I got to do is put them in. And when I put them in, it gives me my final answer of negative 2/3 over x minus 1 plus 2/3 x plus 13/3 over x squared plus x plus 1.